Hey there, my name's Henrik. Glad you can join us live. Today I'm going to be talking about the fundamental way to debug your code. So this is the 8th day of a 10-day series where I'll be teaching about programming. I've been teaching since January 9. I'll finish on January 20. I've been teaching every day from at 8 p.m. Eastern Time. So if you missed one of the lives that I did, you can always watch it on the replay. And you can also join me in the next coming ones. I'm gonna do 2 more after this one. And like I said, this one is about debugging your code. And the reason why I want to create this video is because there's people going to be downloading my personalized finance app programming guide. So I created a guide, and it's called my personalized finance app programming guide. And basically, it teaches you to go from no coding experience to building your first app if you're just starting out. And basically what it does is it takes your credit card transactions, and then you can categorize your transactions in different budget categories so you know how much you're spending. I think this is a fun app that you can learn how to code and also build something that you can actually use for your personal life. And I love building things that I can actually use. There's a lot of projects out there that you can build it, but then it's not really practical. But this is really practical, so I hope that this will be a good app for you. Also, if you don't have a credit card, I do have a transactions file in the guide that you can play with, and you can still do this project even though you don't have a credit card. And again, like I said, actually I haven't said this yet, but the link is in the description. So just download it there, and if you download it and pay attention to what it says, then you'll definitely learn some fundamental programming concepts. Also, before we get started, I'm gonna say that I'm gonna open up for Q&A at the end. So if you have any questions, feel free to ask them at the end. All right, so let's get started. So the fundamental way to debugging your code, and this is the answer. So the fundamental way to debug your code is through prints, or displaying information about the program. Because your computer is doing stuff internally, and it's doing all these calculations, all these executing all these lines of code, but you don't know what it's doing. So what you need to do is you need to get your computer or get your program to spit some information to you. And I think this is what I learned immediately when I started coding in my job. There were a lot of times I didn't understand what was going on. And some of the programs I worked with in my job, there was no GUI, there was no user interface. So what I did a lot was I put print statements in different lines of code just to see where's the program at in different parts of the code. And those print statements were really key for helping me figure out and understand how the program works. And I think this is something you'll find in any program, is something called logs. And basically what a log is it just tells you what the program is doing at that moment in time. And whenever I had products that my company was developing, we always have these logs, and we have different levels of logs. Like if it's very simple logs, like the user logged in, or very simple logs like the program has started, or this part of the program has kickstarted already. Those are simple ones. And then there's more detailed ones where we even go down to the method. There's an error in this method or this function of the program, and it's telling me, oh, this is where the problem happened. So these are really important, and it helped us a lot with debugging our products. And even in my current company, we have our own logs for different parts of the code. So logs basically, in essence, is just a print. It's like a displaying of information. It's a part of the code where the code is telling you what is happening in the code. And I think one typical way we see this in our everyday lives is a 404 error. Have you guys seen that 404 error before in your browser? So that's kind of like a log. It's basically telling you what's going on in the computer or what's going on in the browser. The browser is just communicating to you what is going on, so you're not confused why it's not working. Without that 404 error, you have no clue if it's working, if there's something, maybe the computer is not connecting to the internet, maybe you're not connected to the internet. So these logs are important and helps even the users, not only just developers, but also users, to know what's going on. And also, there's another typical example, which is the blue screen of death. In the blue screen of death, right? You guys know that meme or that popular thing on the internet or in our world, in our digital world now, the blue screen of death. It's when Windows crashes, the OS messes up, and it gives you a blue screen, and it has a frowny face. I wish I could pull it up. I should have pulled it up. But anyways, it has that frowny face, and then you're wondering, my computer's not working, and then you get that blue screen of death. So that blue screen of death, maybe for you, it doesn't make any sense as a user, but it also can give some information to someone who's trying to debug your computer, someone who's trying to figure out what's wrong with your computer. And I think at least it will tell you that, it will give you at least that frowny face that there's something critical, fatal that's going on with your computer, with your OS. So that's another example. And another example that's not really a log or error is the loading screen. So every time you load something or you buffer something, there's always that percentage, right? It shows you 50%, 60%, 70%. It tells you how much longer it takes for you to load something from the internet, or even download something from the internet, or upload something to the internet, or even copying and pasting. How long does it take to copy and paste? Or if you have a lot of pictures, how long does it take to delete your pictures? It will give you that feedback. And all that feedback is like a print or a displaying of information from the program, from the computer, that tells you what is going on. So they have that. And then also, last example I'll mention is for Windows. A lot of times when I was trying to work in Windows, because I don't own a Windows anymore, but in my company we use Windows, so I always have these errors in my Windows. I don't really see errors in Mac, but but in Windows I see these errors, and it tells me, if you want to figure out what's going on, go to this log file. And there's a system called a Windows event log. It tells you basic things that are happening in the background in your Windows machine, and it gives you some feedback, and it'll help you figure out, maybe there's a process, or maybe there's a program that's acting or misbehaving, and maybe it's not installed correctly. And even the process, if you open the task manager and it tells you what programs are being run, that's also kind of like a print. And that's kind of like giving you feedback. So the fundamental way to debug your code is just to print statements. Put print statements in your code, and then you can figure out what's going on. And so this will be helpful in your programming guide. If you're coding your programming guide, and then you have something's not working, then start putting in print statements and figure out where in the code is it messing up. Okay. And I guess one last story that I'll share is, in my company I was working on a UAV, and there's no kind of like command line interface that you have as a user for the UAV. So I had this UAV. Me and my friend were trying to debug why it isn't working, and what we did was we hacked a part in the GUI, and I think the part in the GUI was just to display the wind speed. So we hacked that part, and we took off, instead of printing the wind speed that it's detecting, we put in a different parameter in there just to see if we can, like, sometimes we even put like our own kind of prints, like hello there, or like hi, this is an error, or something like that, or we put our name, and then we can see, oh, we're able to control that part of the GUI. And so when we're able to control that part of the GUI, we can see what kind of output throttle the UAV was generating in different parts. So it gave us a lot of useful information, and I think that's when it hit me that the way to debug your code, the way to debug a system or a program, is really just getting some feedback through a print statement or some sort of that, so you can get some kind of feedback from your computer. All right, so I'm going to do an example, and we're going to do this again in C. So here I'm going to pull up terminal again, and I'm going to go, if you remember from yesterday and the day before, so I had this, I did all of our tutorials in the same exact application terminal, which is an application for Mac. So the way you go into different directories is you do cd. So I'm going to go to cd desktop, go into my desktop, and I have a folder there called Henrik M Dev, which is the name of this channel. You go to Henrik M Dev, and then I have these files. So if you do ls, you can see the files in your directory, and I'll pull up in Finder. These are the files. So this is the file that we made yesterday in my tutorial yesterday, and this is the file I want to use for the example today. And then this is the transactions file we were playing with yesterday. So if you want to see how to read data from a file, then watch my previous video. So we're going to look at the quadratic.c application. Basically what this is, it's just a quadratic formula we can look inside. So I'm going to use the text editor VI, and I'm just going to type VI. I think every Mac should have this application. So type VI and then quadratic.c. And there you go. I would use my text edit application, but I found it annoying yesterday and the day before that I kept on having to fix the capitalization, because it would automatically capitalize my int and the different lines. So I'm just going to use VI for today. So here we have a quadratic formula, and it tells me what the formula is, and then basically it will take a user input. If you don't understand printf and scanf, you can watch my video from Monday, which is different data types. Yeah, data types in C, the basic common data types in C. You can see that to understand more about printf and scanf. But basically it asks the user for a number, and A, and then B, and then C. Ask for those three numbers, and then it calculates the first number with this line of code, and then it calculates the second number with this line of code, and then it prints what it calculated. So let's try it. It's not going to work, but we'll try it, and I'm just going to show you. So you compile code with GCC. You type GCC quadratic, and it will generate a .out file, and that is an executable file that you can execute in your terminal. So you type this, and then you can run your program. So .out, there you go. So that's what I coded. Quadratic formula. There's A. So I have some I have some numbers that I know for sure what the answers are. So I'm going to do 6, and then -5, and 1. And it says x is equal to a and x is equal to 2. So that's obviously wrong. The answer is actually 1/3 and 1/2. So how do we figure out? So we need to figure out what's wrong with the code. So how do we figure it out? So let's look back in our code, and we can look and see if there's something wrong. I think the first thing I would do is I want to make sure that, for example, break this formula, because I see this formula and I see it's very long. So my first instinct is, why don't I break this up into different pieces? Okay, so let's break this up into different pieces, and let's do the b times b. Let's do the b squared section right here, this one. Actually, let's do this whole thing, this whole b squared section. So let's create a new variable called I don't know, let's call it intermediate. Let's call it intermediate. So we'll call it intermediate. So it's an intermediate variable. So intermediate, and then we can do equals, and then we'll just copy this square root. Oh, actually, yeah, let's just copy this square root. Actually, let's just do this whole the numerator. Let's just call it the numerator. Yeah, let's just call it numerator, and then so that the video is not too long, let's do numerator. All right, numerator is equal to this section right here. We'll copy this, and paste. And then what we do is we do a printf, and we type numerator is equals is, let's do %d, and then comma numerator. Okay, and now let's compile this quadratic, and then type in a.out, and then we have 6, -5, and 1. So the numerator is 6. So I forgot to put an inline character here, but it's 6. So is that really the case? So let's calculate it ourselves. Let's go in and see if we type in 6, -5. If we type in 6, okay, so it's gonna be 5. Oh wait. Actually, let's just use Wolfram Alpha. It's a lot faster than me to use my my phone. Okay, so let's do this. Wolfram Alpha. I hope I don't get in trouble for using Wolfram Alpha on my video, but yeah, hopefully it should be okay, right? I don't think they'll get mad at me. Okay, so let's type it in. Let's type in this. Oh yeah, this is the input, right? And then we used, what was the numbers? We used -5, -5, and then we used, and then -5 here, and then A was 6, and C was 1, right? C was 1, yeah. Okay, so it's actually 6. Wow, so Wolfram Alpha can actually calculate it for you, right, even before you press enter. So it's 6. So I have confidence that that's correct. So now I think I can just replace the numerator here, and I can put the numerator here, and then let's see if we get the right answer. Oh wait, actually, hold on. Oh wait, let's do a, let's see, let's look inside again, and then let's put an inline character so we don't get confused. Okay, let's put an inline character here. Okay. All right. Okay, now let's compile it, quadratic.c, and then a.out. Okay, and then what was the numbers we use again? 6, -5, and 1. 6, -5, and 1. Okay, so the numerator is 6. Okay, x is still 18. So there's an issue there. So now let's go back to the quadratic.c, and let's look to see what else it could be there. Okay, now we see, okay, let's try to do the denominator. Okay, so let's do the denominator. And the denominator equals 2 times a. And then we're gonna do denominator. And oh, we need to put a print statement to, okay, so, oops. I forgot some of my Vim shortcuts because I haven't used it in a while, but okay, let's put denominator here. Okay, this is the time when I wish I had used my text editor instead of Vim. Denominator, okay. Okay, let's compile that again, quadratic, a.out. Okay, 6, -5, and 1. Okay, 6 and 12. So 6 and 12, okay, so is 12, does 12 make sense? Yeah, 12 makes sense. 2 times 6 is 12. So I know my numerator and my denominator are correct, and actually if you were to divide this, 6 divided by 12, then you should get one of the answers, which is 1/2, right? So that means, and I'm getting 0. So that means there's something wrong with my, the way I calculated the numerator and denominator. So in my this variable first, I can think, why is it 0? So it gives me I get some feedback here. And I said, why is it 0? So actually, the answer is it's 0 because it's an int, and it needs to be a float, right? Like what we were saying in my other video, if you want a decimal, you need to have a float. Okay, so now we have some idea on, oh, there's a warning here. Oh, okay. So format specifies type int. Okay, so it says %d and then first. So this is good feedback from the compiler itself. The compiler itself is giving you some good feedback through a print statement. So now we know, oh, okay, we're using %d, but it's a float. So we should use %g instead. So let's use %g and then compile. Okay, now it works. Let's start from the top. Okay, 6, -5, and 1. Oh, it still says 0. Why is that? Why is it still saying 0? And at least, okay, so now this one, I think this kind of changed a little bit. So to 2. So it's still saying 0. So let's look at it. Let's look at it again. So your float is first and second are floats. And first is a numerator divided by the denominator. And then I think maybe the numerator is supposed to be a float as well. Maybe we can also try making these, maybe we can try making these floats also. Because first is a float. So if first is a float, maybe we can try making these to be floats also. Oh, now we have all the same error with the %ds. Okay, so let's go back. Oh, we still have a scanf. Oh, the scanf is because these are expected to be %d. Okay, let's keep this as an int, and then let's move these to move the numerator and denominator here. That way we don't have that. We don't have all those problems. All right, 6, -5, 1. Okay, so now we see the 0.5, so that finally we got the right answer. Okay, so there you go. There's an example of how I would try to debug this code, try to figure out what's wrong with my program. And actually, let me just to close this live session, I'm just going to fix everything so that we see, so that we have, just for completion's sake, just so that everything is fixed. So actually the problem was, the reason why it wasn't working was, it was because there was not enough parentheses. So this was one of the issues. We have to put parentheses here. And I think you can kind of figure that out when you have the numerator and denominator variables that encapsulate them, so you can have an idea, maybe the parentheses were not working well. And so let's just copy this one again. Oops. Let's copy this one again. And then we're gonna make it a plus, a -b plus, so we can get the first number. Okay, plus. Okay, I think this should be good now. So GCC quadratic, dot out, 6, -5, 1. Okay, so there you go. So now we are able to we have a working quadratic formula application or program. All right, so yeah, I hope this tutorial was really good for you. I mean, just give you an example of how to debug your code with print statements. I think this will be helpful for you. For those of you who downloaded my programming guide, like I said in the beginning of this live, if you haven't downloaded it already, I have a programming guide called my Personalized Finance App Programming Guide. And in it, if you will go, you can go from no coding experience to building your first app. And yeah, if you pay attention to what it says, you'll learn some good background skills for your fundamental programming. And also, like this tutorial that I just gave, you're gonna have to do you'll probably have to do a lot of this kind of thing to figure out why your code isn't working. All right. Oh yeah, and also let me open it up for questions. Does anyone have any questions? Maybe you can say how far are you in your programming journey? And maybe you have questions about something I did in the tutorial. Feel free to ask. And yeah, again, like I said, if you haven't downloaded my programming guide, hopefully you can download it. The link is in the description, and it'll be really helpful for you if you're just starting out. And I lay out step by step. It's a 12-step guide, and I think it'll be really good. And this is similar to one of the projects I did when I was in university. We also had to have our own files, and then we had to read it. So I think this will be a good project for you. Okay, so if there's no other comments or questions, I'm glad you were able to join me for this live. And sorry I went a little long today. It's supposed to be only like 10 minutes, but it became like 30 minutes. But anyways, thanks for joining, and hope this video made sense to you. Okay, peace.